Welcome. Now, this is From Hot Metal to HTML, the story of typography. Now, as you folks saw at the party last night, have probably worked out by now, I'm not here because I am an expert in domain-driven design. Because I am not an expert in domain-driven design. I used to work with it maybe sort of 5-10 years ago. I got to know Marco and the KanDDDinsky crew, and they were like, oh, you've got to bring the band to KanDDDinsky. And I was like, well, we can do talks as well. And I'm like, all right, so I put in a bunch of talks, like some serious software engineering architecture talks, and I put in this one, which was kind of fun. And they went, yeah, we'll have that one. We'll have the typography one. So, yes, good morning. Now, you know this because this is a title slide, and it tells you the title of the talk and the subtitle, and it tells you me, and my email address is there. Now, if this title slide looked like that sends a slightly different message, doesn't it? You're like, oh, well, this is kind of business, but that's maybe a little bit elegant, maybe a little bit sort of newspapery. Or if I do that, some of you folks at the front are going, oh, I like that. That's modern, that's edgy. Some of you folks at the back are going, what does that say on there? Or if I do this, you're thinking, oh, cool, typography, it's going to be medieval, it's going to be King Henry and swords. Or you're thinking, oh, wow, military, ammunition, stencils, things stenciled on crates. Or maybe we're going to do the Norwegian black metal version of the talk. Or maybe I get up here and I say, hello, everyone, and you're like, Comic Sans at a software conference, really? And after going through all of those, when we come back to this one, this one doesn't say very much, does it? The typography, the font, it doesn't send any message other than, please read these words, the words might be important. And this is intentional because this font, this typeface is called Frutiger. And it was designed by this guy, Adrian Frutiger, for the signage at Charles de Gaulle Airport in Paris. And the project, they said to him, look, we don't want people to be distracted by anything. It's the airport. They're stressed. They're in a hurry. We need a font that doesn't do anything except work really well as a font. And Frutiger had this lovely quote about typography. He said, if you remember the shape of a spoon with which you just ate some soup, then the spoon had a poor shape. Any of you ever used a knife and fork afterwards? You're like, I remember that because it's terrible. If it works, you forget about it. Now, the story of typography starts here. It starts 5,000 years ago in ancient Mesopotamia in the fertile valley between the Tigris and the Euphrates rivers. And this is a big point in human history because for the first time in human evolution, we have started farming. We're not running around hunting and gathering anymore. We're actually doing agriculture. We're growing crops, which means for the first time in history, there is too much food. It's more food than we know how to eat. And the priests pop up and go, hey, looks like you got a lot of food there, friends. I got an idea. Why don't you keep your food in the temple? And then in winter, if you run out of food, you can come to the temple. We'll give you your food back. Which one, it meant the priests never needed to worry about running out of food. But also meant they needed to invent a way of keeping track of who had given the priests how much of everything. And so the origins of typography come from writing like this, clay tablets. Now, to get started with this, we're going to do just a little bit of an interactive quiz here. What I'm going to do, I'm going to show you a picture. And then I'm going to count 3, 2, 1, and I want you all to shout out the name of the country, all right? So it's just a little geography quiz. So we're going to start off with this one here. 3, 2, 1. Australia. Very good. How about this one? 3, 2, 1. Sweden. Excellent. How about this one? 3, 2, 1. Brilliant. This one? 3, 2, 1. Norway. 3, 2, 1. 3, 2, 1. Thailand. Thailand. How about this one? 3, 2, 1. Romania. Anyone recognize this? Canada. Absolutely right, except it's written in Japanese. But in Japanese, these are Canada. Now, this writing style, these are called pictograms. It's a picture that is a picture of the thing you want to talk about. It is a symbol that you will recognize from real life. Now, a lot of the modern developments around pictographic writing stem from the Tokyo Olympic Games in 1964. So the first time that Japan had hosted like a really high-profile international event in the last century. And most international tourists, journalists, sports people cannot read, write, write or speak Japanese. They have no idea where anything is. And so the Olympic Committee, like, we got all these people, different languages, different alphabets, all coming here. We need signs that will show them where to go. And so they came up with a lot of the motifs that we take for granted today. If you're hungry, you look for a picture of a knife and fork. If you are thirsty, you look for a picture of a teacup. If you need to take a shower, you look for a picture like that. So this is pictographic. The earliest writing systems were pictographic. The priests would draw a little picture of a cow on the clay tablet, they'd bake it in fire, and then they'd be like, right, this is your receipt for your cow or your crops or whatever. But over time, they were doing a lot of this, and they kind of got bored of drawing the horns and the ears, and so over time, the cow turned into this. And then what happened is people who didn't realize it was a cow started holding it sideways. And then this started getting into the idea of what we call ideographic writing. Now, how many of you recognize this symbol? It's chat, right? Like, this is all over the place. It's in comic books, and it's in chat applications and things. Now, this is not a picture of anything. Two people having a conversation, they don't get little circles, and you're like, oh yeah, just like in the comics. This is ideographic. It's a thing we have learned to associate with that concept. And something I love is within my lifetime, this thing has gone from being a pictogram to being an ideogram. Because when it first started, it was a picture of the disk you were going to use to save your work. And now there are people out there who have never seen a disk. It's the blue thing with and you know, sometimes little kids will find one and they'll be like, Daddy printed the save icon. And now the thing about ideograms is you need to know what they mean. I spend a lot of time working on Slack with various different teams, and sometimes I'll post a comment like, hey, it looks like the media CDN's just gone out, and somebody will reply with eyes. Now, what do you think eyes means? So one interpretation, eyes means I'm watching this because I want to know what happens. Anyone agree with that one? One interpretation, eyes means I'm looking into this for you. Hang tight, I'll fix it. Who goes with that interpretation? Yeah, see? We got about half and half just here in the room. So if someone replies with eyes, now Slack says the eyes mean taking a look. We're looking at this. I didn't know this because I'd not read the documentation until I'd been working with Slack for a couple of years. This is ideograms, and they only work. So one of the most famous ideograms is, you want to show where the toilets are? You're not going to draw a picture of someone actually using the toilet. That would be gross. But we've learned to associate these symbols with toilet facilities. And flags, they don't mean anything until you know what they mean. Apart from maybe Canada, because it's got the picture of the leaf on it. But we've just had to learn that these symbols mean those countries. It's ideographic. But then the big thing comes along is somebody figures out, they take the cow that's been turned onto its side by this point, and it rotates another 90 degrees as it makes its way across the Mediterranean. And somebody thinks, well, hang on, the Hebrew word for cow is aleph. So what if we just use this symbol to stand for that sound, ah? And then there's another Hebrew word, beth. Beth means a house, and it started out as a little picture of a house like this, and then it got simplified, and then it got rotated sideways, and we ended up with alpha and beta, and we ended up with alphabet, and this is phonographic writing. These symbols stand for sounds, and this is a big deal, because this means that anything you can say, you can write. You don't need to come up with new symbols for every new concept. If a new word starts being used by people who speak your language, you already know how to write it down. Now, human beings have just invented writing. Big deal, great success, pat ourselves on the back. Let's go and invent a bunch more stuff. Now, something that I have always found astonishing is that for 1,000 years, we had paper and we had books, and we didn't have paper books. Because paper was invented in China in around the 1st century AD, and it was used to make scrolls. They hadn't come up with the idea of, flipping pages yet. And books were invented in Europe about the same time, 1st century AD, but no one had thought of making them out of paper because it didn't exist yet. They made them out of parchment. They made them out of vellum, like a very thin kind of leather. So about 1,000 years goes on, so about 1100 AD, finally someone's like, oh, well, we could put the paper in the codex format, and boom, we'd invented books. So we had this whole gap just because there was no trade corridors between those places. Now, all of those early books were written by hand. If you wanted a Bible, you would find a monk, and you'd find a Bible, and you'd give the Bible to the monk and go, can you copy this for me? And the monk would go off to the monastery with a quill pen and sit there for about 2 or 3 years, and you'd get a handwritten Bible. The revolution that happened was the invention of something called the movable type printing press. Now, this is, if you read it like a high school history book, it says that movable type was invented in Mainz, Germany by Johannes Gutenberg in 1552. And it's just like, yeah, he got up one morning and went, I'm going to invent the printing press, which kind of isn't true. It's like how Apple didn't invent the iPhone out of thin air. They had, well, touch screens already exist, and accelerometers exist, and Wi-Fi exists, and all these things exist, but hey, no one's quite put them together like this yet. Gutenberg was the first person to popularize this, generally credited as the inventor of movable type. And to understand why this is such a big deal, you kind of understand what is type and why was making it movable a big deal. Now, in programming, we talk about typing all the time. We say if the type of your type equals type, then you type your program here, and if you press the keys hard, that's a strongly typed language, and if you press the keys lightly, that's weak typing. I'm pretty sure that's how it works. But all of these words, they all come from the same root. It's an ancient Greek word tuptein, which means to strike, to hit something. And the innovation that revolutionized industrial printing was this thing, or it was one of the components with this thing. It was a machine that worked with individual letters. So you could make individual steel letters carved by hand out of metal, which has unbelievable resolution. Like the resolution of steel is fantastic. And then you could use these to make master letters you could then use to lay out a page. Now, the person who first invented this was actually this guy, Bi Sheng. This is in China around 1040 AD, but they didn't have the steel working technology. So the earliest printing systems were made in China. They were made of ceramic. And pretty much no one knows who this guy is, but there is a crater named after him on the moon. So one day people are going to be like, oh, who was that guy? And they're going to go digging, and so eventually someone will look it up. But Gutenberg's innovation, Gutenberg was a goldsmith. He was a metal worker, and he came first person to come up with this idea of, we're going to make a punch. So the punch here is the thing on the left. It's made of steel. It is really, really solid. Then you take the punch, and you take a piece of slightly softer metal, you put the punch on that, and bang, that's the strike. That's the type. And that gives you a stereotype, which is a little hollow mold shaped like the letter. And then you get a load of what's called printer's lead, which is a mixture of lead and tin and antimony. It's quite a soft metal, but you can just pour this and pour this and pour this and make as many of these letter forms as you need. Then you take those, you put them in a grid, you cover them with ink, bang, you've got a page of the Bible. Gutenberg printed less than 200 Bibles in his life, and that took him more than 5 years. The Gutenberg Bible, these things still exist. They go for like hundreds of thousands of euros in auctions and things. These are artifacts of the very dawn of the age of printing. We're going to fast forward 500 years, because 500 years later, 1950s, there are 50 million printed newspapers in circulation a day just in the mainland United States. And the astonishing thing is they are printed using the same technology as Gutenberg. There was no kind of revolution here. There was just iteration of the whole idea. You take a little piece of metal, cover it in ink, stamp it on a bit of paper, and that's how you get it. And a huge part of the innovation there is down to this thing. It's called a Linotype machine. And actually, the whole idea for this talk came from, I went to the Technology Museum here in Berlin about 6 years ago. They have a working Linotype machine there, and I spent half an hour talking to the person running it, and I was like, why did no one tell me this? Why don't you people not tell me these cool things exist? So if you've got a chance while you're here in town, go and check that out. It's amazing. Linotype was invented by a guy called Ottmar Mergenthaler, and it is basically, Thomas Edison said it combines the precision of a wristwatch and the power of a locomotive. These things are amazing. It's like a church organ. It's a thing. It's got a little keyboard on it, and then it's got a crucible full of actual molten lead. It's got a furnace. It's got burning gas. It's got machinery. And the way that they work, the key to them is this. It's in a Linotype matrix. It's a tiny little brass slug with the letter forms. You look closely there, you can see in the middle that the letter forms are punched into the brass here. Now, the way these things actually work is you sit down. This is the working of Linotype. It's an artist called Sylvia Itzigel did this for the Work Museum in Hamburg. So you sit down, you start typing, and you've got this weird keyboard layout, and every time you press a key, one of these little Linotype matrices is going to fall down out of this magazine, slide down one of these chutes, and end up in the collector. And the collector is going to rack these little things up, going to shunt them across here, and then it is going to squirt a bunch of molten lead into the thing you just made. So this is just part of the machine now. This is molten printer's lead in here, and that is going to produce a Linotype slug. You get this little ingot of metal, falls out of it, and then you rack those up, and those are the individual lines of print. Now, the thing which made this machine so clever is once you've got your slug there, you don't need the matrices anymore. And so those are going to get picked up by the machine, and it is going to carry them back up onto the top. And then there's a thing on there called a distributor. Now, every one of those matrices has a little key in it, like the key to your front door. It's got a binary code filed into the teeth. That means it will drop down at the exact right point to rack itself back up again so that it's ready for you to reuse. So these things don't run out of font. They just run out of lead. So as long as you keep putting yesterday's lead back in and melting it down, you just keep doing this over and over and over. They are absolutely wonderful machines. This is in a museum in the UK in Amberley, and this is the last page of a British newspaper ever to be printed using Linotype. And so they take that, they punch that into a wax master, and then they'd use the wax master to make the drum, and this is the thing you see in the movies where they have the whole stop the presses and the spinning newspapers and all that kind of stuff. Now, around the 1950s, there were nearly 100,000 Linotype machines in operation around the world. Actually, one weird quirk, a lot of the best Linotype operators were people who were deaf, because these things made a lot of noise, but you didn't need to hear anything to use them. And so like the New York Times and the New York Post, they had something like 200, 300 people who couldn't hear to work the Linotype machines, because then the noise wasn't a problem for them. By now, I think there are maybe 5 working Linotype machines left in Europe, and they're all in museums, and there's only one guy who fixes them, and he lives in Switzerland, and he's really busy. So if you do try to get a look at one of these things working, it's kind of 50-50 whether it'll be running that day. But Linotype, the company, they still exist because the world doesn't need hot metal printing and it doesn't need printing presses. We've kind of developed past that point. But there is one aspect of the whole typesetting industry which is just as important now as it was in the last century, and that's fonts. And Linotype, the Linotype Corporation, owns most of the world's most famous fonts, Cooper and Franklin and Eurostyle. Anyone seen the Helvetica documentary? Came out a couple of years ago. Linotype owns Helvetica. If you want to use Helvetica, technically speaking, you are supposed to buy it from the Linotype Corporation before you use it. So what's the big deal? Why are fonts such a big concern here? Well, it's all about how you design a font. Now, let's say, classic, the client says, we need a vertical bar. And this is where the designer goes, all right, well, tell me about the vertical bar. What does it look like? Does it have sharp corners? Does it have rounded corners? Maybe, what if we did the vertical bar kind of with a little bit of a flourish on it, so it looked like it had been drawn with a paintbrush or something? And the client's like, no, just a vertical bar, not any of that stuff. You're like, okay, fine. Now we're going to stick across the top of it, we're going to make it a capital letter T. This used to be a tally mark. It's the ancient Phoenicians got this. Well, how tall is it? How wide is it? How heavy is it? Are the lines going to be really thin lines, or are the lines really fat lines? Are the lines going to be the same? Do we want bias horizontal? Do we want bias vertical? Maybe, I got a good idea. Let's give it crinkly edges. No, let's give it rounded. No, let's give it rounded edges with square edges attached to it. That looks pretty cool, right? And now okay, so we've designed a letter T. Let's design a letter Y. Well, straight lines, maybe we curve the tail. Maybe we curve the whole thing. They call this the bowl. What shape is the bowl? Maybe the letter O is a perfect circle like it is on the London Underground. Or maybe it's a square with rounded corners. Or maybe it's a circle, but we're going to just flatten it just a tiny bit. Make it more like an oval. And you know what? We're going to make the middle a little bit thinner, and then maybe we're going to tilt it. We'll put it on its side just a little bit. There we go. We can put a thing down the side. We'll put serifs on that. There we go. We've got a P. Letter E, is it going to be straight, horizontal? How high? How low? Is it going to be at an angle? Are we going to have serifs on it? Maybe we're just going to make the whole thing look like it was drawn by a kid using a crayon. Now, designing a typeface, every single letter, the Latin alphabet, the Cyrillic alphabet, the Greek alphabet, all the digits, all the punctuation, every single one of those is a product of all of these decisions. And historically, people did this by hand on paper. This is the original handwritten illustration for a font called Johnston, which was designed for the London Underground Transport Network, one of the world's iconic fonts. And like I said, you want to recognize this one, the O and the Q, they're perfect circles. That's a dead giveaway that you're looking at the London Transport font. So they would design this on paper, and they would draw master designs for every letter. Then they'd give that to the metalsmiths, who would file this stuff into the punches, and then you would get the font. Now, in Word, you want to change the font, it's just a drop-down. On a Linotype machine, if you want to change the font, you need to get a friend to help you, because the font is a magazine with about 75 kilos of metal in it. So you need someone to help you rack that thing up. Now, while all of this is going on, this astonishing precision with hand-carved letter forms and everything, something else is going on, because this is the 1970s, and computers are just getting started, and a revolution is about to kick off. Now, computers aren't new. The PDP-1 has been around for about 20 years, but most computers up until this point were connected to teleprinters, like a mechanical typewriter that does all your input and output. They had screens, but the screens were used like oscilloscopes. They weren't really used for text output. Now, we can't really tell the story here without touching on this bizarre little anachronism from 19... So this is Radio Electronics magazine. And if you look closely, for men with ideas in electronics, because the 1970s kind of sucked in a lot of ways. But this magazine had the designs for something called a television typewriter, which was a machine you could build that you could push keys and they'd come up on your TV screen. Now, you couldn't save, you couldn't edit, and you couldn't print. So you couldn't use it to do anything. You couldn't send someone an email, you couldn't print your letter, you couldn't save a document. What you could do is you could get letters on the TV screen. And I guess there were people out there who were like, I don't care, that's really cool. Look, I put letters on the TV. But a lot of the kind of thinking around how raster displays developed comes from projects like this one. Now, ASCII has been a standard for over a decade. It's used by pretty much everybody except IBM. So we're going to go through what happens. So you're on your early microcomputer, like mid-1970s, and you are going to press the letter A on your keyboard. And so inside your keyboard, there is a chip that says, well, we know what A is. A is ASCII code 65. And then it's going to look that up in a character generator, which is just a massive dictionary of ASCII code to this number here. And the reason this number is important has nothing to do with the number. It's to do with what that number looks like written in binary. Because if we take that 32-bit number in binary and we map it out into a 5x5 grid, what we get coming out the other side of that is we get this shape. And so the keyboard maps to the ASCII code maps to a 32-bit number, the 32-bit number literally bit map. It maps the bits onto a grid, and that's how your computer knows how to draw the letter A. Now, around 1984, the Apple Corporation come out. They had this astonishing commercial. They ran a commercial in the Super Bowl talking about how 1984 wouldn't be like 1984 because they were about to launch the Macintosh. And the Macintosh was amazing. It wasn't like any computer anyone had ever seen. One of the first computers that had different fonts. And most of them were designed by this lady, Susan Kare. And Apple didn't want to pay Linotype for font licensing. So they got Susan to design a set of fonts. Some of them were replicas. They had one called Geneva, which was clearly like a sort of Swiss-influenced Helvetica typeface. And they had one called New York, which was like a Times New Roman newspaper font. And some of them were completely original. There was one called Chicago, which was big in the 80s, and it kind of went away for a while. But then when they brought out iPod in the early 2000s, they used the Chicago font from the original Apple Macintosh. But the most powerful computer that Apple sold in 1984 was not the thing on the right, it was the thing on the left. Because the thing on the right, that is the Apple Macintosh, which had a 12 megahertz CPU, or 8 megahertz CPU. The thing on the left is the LaserWriter. It's the first consumer laser printer. It was twice as powerful as the computer next to it. 12 megahertz CPU, it had 512K of RAM, it had a 1 megabyte frame buffer, which was unimaginable in the 1980s. And the reason why is that the Apple Mac was the first computer to do what would become known as desktop publishing. You could do a document on your screen, and then when you printed it, it would look the same. Now on screen, it's using bitmapped fonts. It's using that technique we just looked at, where the font is a number and the number is a map, and that's the grid. And bitmap fonts have a problem. They look really good when they're tiny, but when you make them bigger, they kind of don't look very good. So all of the fonts that shipped with the Macintosh, they came in two versions. They came in a bitmap version for the screen, and they came in what was called a Postcript version for the printer. And the way this worked is instead of using bitmaps, it described the font using mathematics. Now let's say we want to draw a circle. We want to draw a dot. And we're going to work in inches because even countries that have always used the metric system, printing works in inches. Dots per inch, DPI, that's just how stuff works. So we're going to draw a circle, which is a 4-inch by 4-inch center. It's a radius of ½ an inch. So we now have a little function, and we're going to say for each point, we want you to say, well, if the x and the y coordinates squared are less than this, then you paint that point, otherwise you don't paint that point, which is not complicated mathematics. But now we need to repeat that for every single point. So the higher the resolution, the more calculations we need to do. The LaserWriter could do 144 dots per inch. So we need to do 20,736 iterated floating point calculations to draw a 1-inch circle. That's why the laser printer had more power than the computer, because that's where all of this calculation happened. Now we want to draw a letter O. Well, now we've got to figure out which ones are inside that circle but outside that ellipse. Or maybe we want to draw a letter B. So the mathematics that's encoded into the font looks like this. And we're like, all right, so we need all the ones that are inside there, but they're not inside there. Now, these letter forms are beautiful. They are crisp, and the curves are perfect, and the better your printer, the better they're going to look. And that's where the processing power, the overhead was. And so for a long while, we had this kind of side-by-side thing. Now, the typefaces in the LaserWriter were owned by Adobe. Adobe owned Postcript. And computers got better, chips got cheaper. By the kind of late 80s, early 90s, everyone kind of figured out, look, at some point, we're just going to use the same fonts in the computer that we use in the printer, because the computer's going to be fast enough to do all the maths and draw the nice letters. And Apple and Microsoft did not want to pay Adobe to license their Postscript font engine. There were two problems with it. One, it was expensive. Now, the other one was putting vector fonts on screen. So here's our letter B, but we don't have 144 dots per inch. We've got a display. We've got like a VGA screen from the early 90s. So we need to draw our letter B. Now, what if we just color in all the pixels that are entirely within the outline? Not going to work. All right. Well, what if we color in any pixel which is like more than 50% within the outline? And now you can see it's a B, but it doesn't look terribly like it's going to look when it comes out of the printer. So what if we kind of, fudge it, and now things start to get a little bit blurry and a little bit smudgy? And so the great innovation that Apple and Microsoft came up with was something called font hinting, where they could take the font, but then they could go, right, we're going to draw this 8 pixels high, which means we're not actually going to draw that, we're going to draw this. We're going to put fonts, little hints in for every font, every resolution, to tell you exactly which pixels need to get filled in. Now, this was called TrueType. And TrueType didn't make it in time for Windows 3.0, but it did make it for Windows 3.1 and for Apple System 7. And to this day, if you go in and take a look in the settings, you boot this up I actually booted this in a VM to get the screenshots here, and you will see this little snippet there that says this is a TrueType font. It'll be the same on your printer and on your screen. And if you look in really closely, you can see the hinting. You can see where somebody, just like the old type designers working with metal files, by hand has gone that one there, that one there, that one there, and make it look as good as we can at these kind of fairly low displays. Now, the next big innovation that happens in the history of typography, it's not a piece of technology or anything. It's a font. Because there was a thing called Microsoft Bob. And Microsoft Bob was a lovely, if slightly naive idea at making computers more user-friendly by making them work like a comic book. So instead of having a desktop with icons and files and folders, you had a nice living room. And if you wanted your appointments, you would click on the calendar on the wall. And if you wanted to look in your recipes, you'd go into the kitchen. And for some reason, Microsoft Bob had an electronic dog who would talk to you. And there was a type designer called Vincent Conner who was working at Microsoft in the 90s. He saw a preview of Bob, and he's like, this is interesting, but why is the dog talking to me using Times New Roman? That's not a very comic book type typeface. I've got an idea. And so Vincent Conner came up with Comic Sans. It's a sans-serif font, so it doesn't have little crinkly edges, and comic book in style, so Comic Sans. Now, Microsoft Bob died, because they took it outside and buried it and shot it. And I think it was Steve Ballmer said later, Microsoft Bob was a great example of a project we should have killed earlier before anyone ever found out about it. But actually, the biggest legacy of Microsoft Bob is it's the project where Bill Gates met his wife. So Bill Gates got married because of Microsoft Bob. That's probably the only person who got any benefit out of it. Comic Sans did not quite make it in time to ship with Windows 95, but then a year later, Microsoft launched a thing called the Windows 95 Plus Pack. And that included Comic Sans, and lots of people went, oh, this is nice, look at it. Now, Comic Sans is a perfectly good typeface. It is clear, it is readable, it is friendly. It is the people using it that is the problem. If you want to invite people to your daughter's 6th birthday, Comic Sans. If you're making a little app about a talking dog who helps you find your appointments, Comic Sans. If you are sending the invoice for burying someone's husband from your funeral home, do not use Comic Sans. There are entire websites out there dedicated to Comic Sans showing up in places that it really shouldn't, like counseling centers for crime victims and police stations and stuff. And this is why designers hate it. It's not because there's anything wrong with the font. It's because people misuse it. They use it because they don't understand the message that the typography sends. Now, 1990s, Comic Sans has come out, Windows 95, the Plus Pack is around, TrueType fonts are there. This is all fantastic. The next big innovation we get is the shift from these monitors to these monitors. Because cathode ray tubes are being phased out, we're starting to see flat screen displays. And there is a really interesting property of a modern flat screen display. Have you ever taken a screenshot and zoomed like way in? Like way. You zoom in, and if you zoom in close enough, you'll see you've got little colored fringes. Like the T there, it's got the left side of it is orange and the right side of it is kind of blue. And it's not a color font. You know, this is just black and white. This is monochrome. Now, if you zoom in using like Photoshop or the magnifying tool, this is what you see. If you zoom in using a macro lens on an actual camera, what you get isn't this. You get this. Because every pixel on a flat screen display is a red element, a blue element, and a green element. They are normally organized side by side. And during the 90s, somebody apparently at Microsoft, but we'll talk about that in a second, figured out that that meant that if you just draw the blue pixel, what you actually do is you're going to draw the left-hand third. You've effectively tripled your horizontal resolution because you can switch on and off sub-elements of each pixel. And so by using these color things, you get the difference between this and this. You get triple the horizontal resolution. Now, Microsoft called this ClearType. They announced it in the 90s. They filed a patent on it, all kinds of, yay, this is awesome, brilliant, well done, big innovation. Except there's pretty strong evidence that, one, they didn't invent it, and two, they knew they didn't invent it. Because this is the Microsoft Basic Interpreter Reference Manual from 1980 for the Apple II. Because Microsoft wrote a version of Basic that ran on the Apple minicomputer, a microcomputer. And there is a note in here talking about a hack that the Apple used to get high-resolution displays by lighting up 1/2 of a pixel element. Now, I have no idea whether Microsoft found this and then they forgot and then all those people got fired and then somebody else discovered it and they didn't know they'd discovered it before, or whether they just went, don't tell anyone about the Apple thing, we can pretend we've invented this. They probably all forgot. But that's the history of it. The big celebrated accomplishment they had in the 90s, they didn't actually invent in the 90s. It was invented by Steve Wozniak about 20 years earlier, and we know Microsoft knew this because they wrote about it in the manual. Now, one of the cool things about that was the reason Steve Wozniak invented it is because he wanted to be able to run a terminal emulator on the Apple II, which had a 280 by 192 pixel display. And while we're talking about tiny, tiny fonts, there's a guy called Michael Koss who created this. And I thought this was the smallest font ever created. Every letter in this font is 5 by 3 pixels. So it takes 15 bits, so you can fit the bitmap in 16-bit numbers, so it's incredibly tiny, but it actually includes the full ASCII character set. And I did a version of this talk at Build Stuff a couple of years ago, and someone came up to me afterwards and they went, that's not the smallest font. And I'm like, no, don't be, no. Someone has made an even smaller font that looks like this. And what this is doing is it's a 3 by 5 font, but instead of using 3 pixels, it's using the red, green, blue of individual elements. So it looks like this, but if you look at it under a magnifying glass, it's 0, 1, 2, 3, 4, 5, 6, which just makes you go, no, come on, human beings, step away. Now, around the 90s, we got a couple of interesting things going on. TrueType fonts is out there, and the 90s was also the age of CD-ROM. And CD-ROMs were great because they would put the program on disk 1 and then be like, well, let's give them some more stuff to justify the fact this costs hundreds of euros. So you would get another disk which was packed with clip art and fonts and fonts and fonts and fonts and all these fonts. And so the world was like, yay, we've got so many fonts. And then the web comes along. And they're like, what happened to the fonts? And you're like, oh, we don't have fonts on the web. We got Times or Arial, that's pretty, or Monospace, we can do that one. And they're like, but we want our website to be in our company font. And you'd be like, well, you can't have your website. Really sorry. You're on dial-up internet. Your company font is 5 megabytes. No one is going to wait 3 hours to download a font just so they can see your website in your company font, Arial or Times New Roman. You get to pick one here. Now, the early days of the web, there's actually some great little relics and artifacts out there. Does anyone remember when the web looked like this? This is the Space Jam website that Warner Brothers set up, and this is still out there. Like, first of all, they set it up in the 90s, like Space Jam, the movie with Michael Jordan and Bugs Bunny, which obviously makes perfect sense. And then they kind of forgot about it for 15 years, and it was just still there. And then someone at Warner went, this is like a museum piece now. We need to preserve it. And so the Space Jam website is still online with its original web typography. Now, one thing you could do with the web is you could say, well, you know what? Maybe someone already has this font installed. I used to do this because the client would want the font in their website and they wouldn't listen to reason, but it's like, okay, well, you've probably got Futura semi-bold because that's your company's house font. So you could put this in your CSS. And if you've got Futura semi-bold, it'll use it. And if it doesn't, it'll fall back to Helvetica, and then it'll fall back to Arial, and then it'll fall back to sans serif. Now, there aren't a whole lot of takeaways in this talk. But there's a little tip I want to leave you with. This is something fun you can do. And to do this, you need three things. One is you need a colleague who maybe you don't like very much. The colleague needs to be running Microsoft Windows, and you need a copy of this. FontForge is an open source font editing tool. So what we're going to do is we are going to go over onto dafont.com, and we're going to find a really, really groovy typeface. Like Abstract Groovy is probably a nice one. We're going to download that. This is free. It's open. You can do what it's. I've deliberately chosen one here with no restrictions on the permissions. So we're going to download Abstract Groovy. And then what we're going to do with that is we're going to, come on, this should be playing video any second now, any second now, any second now. Nope, all right, it's not going to do that. All right, we're going to open it up in FontForge. There we go. And we're just going to open the font. We're going to go into the font metadata, and we're going to change its name. I'm going to change its name to Helvetica. Helvetica Neue, which is the really cool, crisp font that Apple launched when they came up with the Retina display for iPad. And we are going to rely on the fact that when we send this font family, this font face to our colleague, we are going to save this as abstractgroovy.ttf, and we're going to generate the font file for it. We're going to send it to them and go, hey, check out this really cool font we found. And they're going to double-click it, and it'll open up, and they'll be like, yes, install that for all users. And they're probably not going to notice that although the file says it's called Abstract Groovy, the font thinks it's called Helvetica Neue. Now, the reason we've chosen Helvetica Neue is that lots of websites that are trying to be really cool, they use Helvetica Neue, but on Windows, you're used to that font falling back to Arial because Windows doesn't have Helvetica. So they're not going to notice anything for a couple of days. And then they're going to go to download WhatsApp. And I'm like, oh, WhatsApp's got kind of groovy. And then maybe they'll buy something from the iTunes store and they'll get their Apple receipt and like, Apple is getting the whole 70s disco vibe going on. Or they'll try to log into their business accounting software. Now, the reason I know about this is because I had this happen to me by mistake. I had a client send me a Helvetica font they wanted to use, which was just awful. It was like some bootleg dodgy, like they bought Helvetica from Temu or something. And I installed it, and I forgot that I'd installed it. And after about a week, I noticed that a bunch of websites just didn't look right. And it took me a long while to figure out. They were all websites that were using Helvetica, Arial, sans serif. And so on Windows, I normally saw them in Arial. I'd installed this font, it meant suddenly Helvetica was available. It's just it looked like garbage. Now, if it's bad Helvetica, it makes it look like garbage. If it's Abstract Groovy, it just makes the whole web like a really funky place to be. Like you can join the digital interbank network and you're like, yeah, with my flares and my roller skates. Now, the interesting thing about web typography in particular is typography goes back centuries. You know, ever since the Gutenberg Bible, ever since the illuminated manuscripts and people drawing Bibles by hand, people have been thinking about how to use type effectively, how to use layout, margins, weights, how to align things, kerning, spacing, all this kind of stuff. Whereas the web was a bunch of hackers in the 90s going, wow, we've just invented this thing, and coming up with apps that look like this. And on one side of this balance, we have the design people. And you know, you can go out there and you can buy literal textbooks about how to teach the history of design. That is how deeply rooted these ideas are. This is how long they've spent figuring this stuff out. And over here, you've got us going, lol, look, I put two heads in the page and I used this CSS IE workaround that I found on Stack Overflow, and it kind of works cool. And these two things bang together, and yeah, it creates a certain amount of friction. And so web typography took a little while to get going because the people who were good at the tech didn't understand the layout, and the people who were good at the layout, you know, go to a designer, they're like, yeah, I'll design something for you. Then say to them, oh yeah, we don't know what size the page is going to be. I've seen people have meltdowns over this in the 90s. Like, well, how can I design if I don't know how big the page is going to be? And they're like, well, it's a computer. And they're like, well, can't they print it out? And like, they're not going to print your website, Brian. That's not how any of this works. Big step forward happened in 2009 with the web open font format and a big push from the web typography thing. Now, up until this point, there were certain applications that used fonts in interesting ways. Has any of you here ever received an email that just weirdly ended with a letter J on its own? Now, I used to get this from time to time, and I worked out after a while that it only happened on, because I was working at a company that used Outlook and Exchange, Microsoft, but I had an iPhone. And so when I read my email on my phone, it was a J. When I looked at it at work, it was a smiley face. And the reason was that Microsoft Windows shipped with this font. It's Wingdings. And Wingdings includes like playing card symbols, and there's a thing, printers dingbats they were called. The old mechanical movable type printers, they'd have a little thing of like bullet points and flowers and playing cards, and for some reason they called those the dingbats. And so Wingdings was dingbats running on Windows, and one of those was, now the way this worked, it wasn't new code points. It was just, all right, well, if you're using this font, then an A is like that, and a number 2 is a document, and a W is a diamond like this. Now, about the mid-90s, a journalist working in New York discovered that if you type NYC in Wingdings, you get a skull and crossbones, a Star of David, and a thumbs up. And so, being a responsible journalist, no, what they did is they called the New York Post and went, Microsoft wants to kill all the Jews. Because New York City, and of course they ran a sensational story on this, and Microsoft went, don't be ridiculous. It's nothing to do with that. This is just arbitrary font mapping. There's no conspiracy here. Just shut up and take your medication. But when they announced Webdings, which came out in Windows 98, 1997, they made absolutely sure that they were not going to get a repeat of this, because if you type NYC in Webdings, you get I love New York, which I thought was just like it's not a conspiracy, but you know what? We don't want this thing to happen again. And the reason why you got emails ending in J is that the little smiley face would get auto-corrected, and the smiley face in the Wingdings font was the letter J. And so if you had a Windows machine, it would render it on Outlook as a smiley face. Anything else, just come up with this weird letter J. Now, web fonts are brilliant because you can use them for more than just letters. There's a fantastic site out there called Font Awesome, and this gives you libraries of user interface elements, playback buttons, download buttons, even astromech droids. You want to draw R2-D2 on your website somewhere? You don't need to find an image. You can do it using a character in a font. And the wonderful thing is, because these are vectors, because these are mathematical descriptions of letter forms and glyphs, as screens get better and better and better, these just look better and better and better. And so the evolution in displays we've had from Kindle to e-ink displays. Now, the way that a Kindle display works is actually pretty amazing. Because the first time I saw a Kindle in a store, I was like, that's fake. Like, can I see a real one? And the salesperson was like, that is a real one. I'm like, no, it's not. That looks like paper. And they pushed the button and it turned the page. I was like, holy, yes, I'll buy it. I don't care how much it is. I need that. And the way they work, they only draw power when they're turning the page, because every pixel on a Kindle screen is a tiny little bubble with a bunch of white magnetic particles and a bunch of black magnetic particles. And when you apply a current, they swap places. But once they swap places, they just sit there forever. They never move of their own volition. You don't need power to keep the display active. And so this was the kind of e-ink revolution, and this in turn triggered people reading more and more long-form, prose and textbooks and novels and things on digital displays. And then a couple of years ago, I upgraded my Kindle to one of these. This is a thing called a Books. It's an e-ink tablet that you can write on, so you can use it to do crossword puzzles and stuff. And they just brought out a color e-ink display, so now you can get e-ink with color on it on the Books device. It's not like Technicolor, it's more like watercolor color, but it's pretty good. It's a kind of big innovation step forward. And of course, all of us out there using things like modern smartphones, the pixel display on these, my phone is now better than my eyes, and my eyes are only going to get worse, and the phones are only going to get better. So as far as I'm concerned, we've solved the problem of displays. It's just a done thing. What we need to do now is make them bigger, But we as developers, as people working in technology and creating applications and experiences here in 2024, we're at this kind of this inflection point, because we've got one story here, which is 5,000 years of innovation around how do we make letters? How do we make alphabets? What does writing even look like? And that's still going on. The eyes emoji, that happened within the last maybe 10 years as an example of human beings going, hey, we need a new sign to represent this thing that we didn't really have before. We've got a story that is 500 years old, which is about print. It's about information design and layout and typography. We've got a story which is about 50 years old, which is the story of how we do this stuff on screens, and bitmap fonts and TrueType fonts and all this kind of stuff. And then we've got, where are we going from here? We have this wonderful convergence of these three things that have put this amazing technology right there where we can go out, we can plug into it, we can work with it. And I had a moment a couple of years ago. I read this book in the 90s. This is The Diamond Age by Neil Stephenson, which at the time it came out was full of stuff that was just unbelievably futuristic, like nanoprinting and molecular manipulation of diamond and all these kinds of things. And it's the story of a little girl who has a smart book, which is basically like her digital babysitter and tutor and everything. And I was rereading it. So this is my old paperback copy, which has been, battered around the world a couple of times. But I got it on Kindle. And there's a passage in this book where the protagonist is reading her book at night, and it says that at times like this, the paper glowed softly and the letters stood out, crisp and black, like tree branches silhouetted against a full moon. And I had this moment of, holy shit, it came true and I'm holding it. I was literally reading about an unbelievably futuristic digital book on an unbelievably futuristic digital book that I was just sat at the railway station because I was waiting for my train. And it's like, okay, wow, we actually live in the science fiction. It's coming true right now. And we, developers, we're the ones who are out there taking all these things like the television newspaper. Will you ever be able to get your news on your television screen? Like, yeah, well, it's not a television anymore. But yeah, all of these things, all of these kind of, unbelievably ambitious science fiction prophecies are coming true all around us. And so I love looking at old kind of books that predict the future and being, how much of this stuff is real? How much of this is true? How much of this is already happening? And how can all of us as developers, what can we use? What can we plug into? How can we build awesome stuff and ship products that our customers and our users are going to love? So folks, get out there, build awesome stuff, enjoy the fact that we have these centuries and millennia of innovation to build on, and thank you very much. Or rather, thank you very much in Helvetica Noi.